Welcome to the session. I'm Sai Valuri from the Database Product Marketing team, and I will be moderating today. This webinar is a part of the Oracle at Oracle series, where you have the opportunity to hear from the executive team that's reimagining Oracle. In this series, we share insights from our own journey to the cloud and demonstrate how we are using Oracle solutions to power our business and enable exceptional customer and employee experiences, and then share what we have learned so you and others can do the same. Let's dive into today's topic. Over the next 45 minutes or so, we will share how Oracle builds internet scale applications with Oracle Database on Oracle Cloud Infrastructure. Now, I'll hand it over to your hosts, Matt Abrams and Shailesh Dwivedi, to introduce themselves.
Welcome, everyone. Thanks for joining us today. My name is Shailesh Dwivedi. I am the product manager for Oracle Database Sharding. I am joined here by Matt.
Hi, everyone. I'm Matt Abrams. I am in the product development organization for Oracle Data Cloud, where I'm responsible for the Oracle Blue Sky DMP, Data Logics, AddThis, and overall infrastructure. Prior to joining Oracle, I was the CTO of a company called AddThis, which ran what was effectively one of the largest websites in the world. And so I'm excited to be here today to talk with you about how we used Oracle ShardingDB to help improve our architecture for the Oracle DMP.
Okay, so Matt, can you please start by talking a little bit about what Blue Sky is and what application challenges we have there?
Absolutely. So the Oracle Data Management Platform, its primary purpose is to collect, organize, and activate first and third-party data from any source. This platform enables marketing organizations to personalize online, offline, and mobile marketing campaigns with actionable information about targeted audiences. For the purpose of this webinar, the important thing to understand is that the Oracle DMP is a massive data collection platform. It receives roughly 30 billion API calls per day from websites, mobile applications, and direct API calls. The DMP needs to quickly process information from these calls in order to provide the caller with some actionable information. In this webinar, I'm excited to share how we were able to use Oracle ShardingDB to simplify our architecture, improve performance, and operability of the platform.
So Matt, we touched upon the scale of the application. So could you talk about the customer base of the application and what actually contributes to the large volume as well as transaction volume of the data?
Absolutely. So the Oracle Blue Sky DMP has some of the largest publishers in the world as customers, as well as some of the largest data providers in the world. And the magic is when we're able to combine data from all of these different data sources and all of these premier publishers and data providers into a common platform so that we can get leverage that's far beyond what you could get from any single data stream. So we have over 200 plus delivery partners, 250 plus data sources, and these data sources are both offline and online data sources. And we break this data up into almost 30,000 different data attributes, and we're used by 80% of the top ad networks in the world. So what we're talking about here is the backbone of the ad tech industry across the internet.
Well, that's a very fascinating application. And if I look at the data volume, they also look fairly staggering numbers here in terms of transaction volume, in terms of the entire database size and extreme latency. So could you please walk us through some of the numbers and explain what is going on behind these numbers and why they are critical to the application?
Absolutely. So, as we've been discussing, this platform is large. It's large both in terms of the velocity of calls, how quickly calls are coming into the platform, and it's large in terms of the total data stored. So any one of these numbers on any dimension is large when compared to a typical database, a typical website. But when you put them all together, it's truly an impressive piece of infrastructure that's required to support something like this. And seeing 1 million transactions per second, that's impressive, but it's not necessarily unheard of. We see 1 million transactions per second in a lot of different applications these days, but 1 million transactions per second, which includes an ACID compliant database call, that's something that's fairly unique. So every time a web event comes in, or any kind of event comes in, we need to process the business logic associated with that event, but we also need to make a read and a write to the database. So we're effectively doubling our API rate with reads and writes to that database. We do this across roughly 52 servers, and keep in mind that's with redundancy. So we're talking about serving this entire platform on less than 25 or so servers, which is quite impressive from my perspective, across 2,704 cores. It's a very specific number, but the point there is this would be hard to accomplish with a vertically scaling database infrastructure. It'd be hard to find a way to scale up to this level and not have the application have to handle the logic of partitioning the data across multiple database instances. With Oracle Sharding DB, we're able to get that massive scale, 2,700 cores and 38,000 gigabytes of memory in one logical database. And our application treats it as if it was a single database sitting on one server. And that really simplifies our application logic. And then when you think about a terabit per second of network traffic, we're sending large data objects across this backbone, and that wouldn't be possible without OCI's network data plane that's capable of providing that service, not just between servers in the same data center, but across availability domains and eventually across regions as well.
These are really, really staggering number, Matt. I would think this is probably one of the biggest online transaction processing database, a single database, as you said before, probably in the world, if not the biggest database. And I see that we have about 2.5 petabytes of data here, and still our read latencies are around 1.6 millisecond per API call, when write latencies are 2.5 milliseconds. So what constitutes these latencies? Are we using any caching, or we are hitting directly the disk, and this is an end-to-end latency?
There's zero caching. When we're designing architectures, we try to keep them as simple as possible. And often the solution to a latency problem is inserting a cache. And now you have a latency problem and a caching problem. And so, the power here is that we can use the magic of sharding. By splitting the data based on a partition key across multiple servers, we're able to split this problem into data domains that are small enough to achieve these types of latencies. So the query APIs, the interfaces know where to find the data. The data is able to be kept warm in that 38,000 gigabytes of memory. And we're able to achieve pretty astonishing latencies in terms of these reads and writes, because ultimately, if we're sitting on a publisher's website, or we're sitting in a mobile application, if our APIs are slow, our customers' websites are slow, our customers' applications are slow, and that's just not acceptable. And in fact, we lose data when that happens. So when we were thinking about this project, this was our #1 criteria. And our goal was actually to have our latencies below 5 milliseconds. So we've actually achieved that and then some with this outcome.
Yeah, very cool. And especially if I see the payload for each API call is not minuscule, it is 125 KB. And what I find really interesting is the redo generation rate. I mean, those are, again, as I said before, unheard of numbers, 180 terabytes of redo per hour. Those are really fascinating numbers. So as we move on, let me give a quick overview of what sharding is and how it works, especially how Oracle Database Sharding works. And then we will take a look at how we are leveraging these capabilities in the Bluekai deployment. So sharding, as we all know, has been the dominant approach for scaling internet applications, whether it's a search-like application, social media, emails, streaming data, etc. So these kind of internet scale applications have been using sharding to achieve the planet scale or global scale. Effectively, what it is horizontal partitioning of data across independent databases. And as Matt alluded earlier, each of these database instance holds a subset of data. And there is no single point of failure in this architecture as we look further. So all shards are protected for high availability and disaster recovery. It uses a shared nothing architecture. And by that, we mean that there is no specialized hardware or software required. There is no need for a special SAN storage or a network attached storage or network cards or host part adapters, NICs, etc. So these are all, they all can be commodity hardware spread across many machines. Additionally, sharding supports massive parallel processing architecture. So things like scatter gather, where you want to fan out a query across these multiple machines, and each of the machine runs in parallel on the subset of data it has, and the results are aggregated and returned to the client. So on the right side in this picture, what I'm showing is that let's assume we have a single database, and we have, say, 3 machines here, server 1, server 2, and server 3. And each of these machines is running an Oracle database shard. Oracle database shard is nothing but a regular Oracle database instance, which is independent, fairly independent of other shards. So we call that a shard. And let's assume we had a table in this database called table 1. Now, if this table had, say, 300 rows, then what we do with the Oracle database sharding is that we spread the data across these 3 machines. So let's say row number 1 to 100 is on machine 1, 101 to 200 is on machine 2, 201 to 300 is on machine 3. So that way we took a single table for a single database and we partitioned the data across multiple machines. Now, what we have also done is we have enhanced our the JDBC driver, Universal Connection Pool driver, C, C++, Python, Go, all the different drivers with which the applications connect to database. They understand sharding. They understand this data distribution and data placement. So at the runtime, when application wants to query a data for a given sharding key, as we call it, which is something you can think of is the way you are partitioning the data, in this case, say customer ID, then the application gets connected directly to the node where the data is residing. So for example, we ran a query for customer ID 1, our drivers, without you having to change the application, connect directly to, say, server 1 in this case, where the shard number 1 is residing. Additionally, we also support parallel processing and multi-shard queries for that matter. So for example, if you want to run a query where the data resides in all these 3 shards, an example could be select count star from customer, where I want to know all the total number of customers which are spread across all these shards. We have a component called multi-shard query coordinator, which pushes this query in parallel to all the shards, and each of the shard executes that query in parallel on the subset of data it has, and the results are returned back to the coordinator, which returns it back to the client. So in effect, from an application point of view, from an operations point of view, it's a single logical database, but the technology on the database side as well as on the client side abstract this fact that it is spread across multiple machines. We actually support up to 1,000 shards which can be deployed in this manner. So what are the benefits of sharding and why we see customers adopting sharding? So number one, as Matt said, reason is linear scalability. And by that we mean is that if you have more transaction volume, more data volume, you can linearly, horizontally scale your application by just continuing to add more nodes. So this actually gives us a straight line 45-degree scalability because the architecture itself is so simple that you add more nodes, you get more transaction out of that, and you can handle more data volume. Additionally, it also gives us the elasticity. I often talk about it as something as a stateful elasticity, where because of, say, seasonality, where you have more data or more transaction volume go in a given period of time, so you can add your nodes and scale out your database. And once the season is over, for example, your holiday season is over, then you can shrink the number of nodes in the database without losing data. So sharding allows us to do that, where we can add nodes and remove nodes based on the seasonality or based on the scale out requirements. The second big reason why customers use sharding is for extreme availability. And as I said before, there is no single point of failure. So if one of the node goes down, there is automation where the failover happens transparently to the application. Application doesn't even know that there was a failure and it got failed over. But some of our customers are looking at, say, 4959 or even 69 SLAs, where they want to reduce the impact of even a blip or a small brownout because of these outages. So it's about containing the blast radius, that an outage on one node, in this case, does not impact any other node. Even a small blip or brownout, if that happens on, say, node number 2, then only customer 101 to 200, if I continue on my previous example, would potentially get impacted. All other nodes are healthy and serving the traffic, and it has no impact at all on the availability of the data in other nodes. The third big reason we are seeing customers adopting sharding is because of geographic data distribution or global databases. Now, a lot of our customers, or most of our customers, are global. They have applications which are global in nature, and their customer base is also global. The users using those applications are global. Now, because of data sovereignty requirement, data residency requirement, we have regulation now where data is required to be within a certain geographic boundary. For example, United States data should stay in US. Countries in European Union require data to stay within the bounds of Europe, etc. So there are many such regulation and requirements which require data residency. As I said before, the applications are global, the customers are global. So what sharding allows us to do is to have shards, as we call them, in multiple regions, in multiple geography, and treat it still as a single global database. So from an application point of view, it's a single database. From an operational point of view, it's a single database. The application connections get routed automatically where the data resides, but the data does not leave the geographic boundaries where it is supposed to be. So that gives us a true global database, as well as honoring the data residency and the data privacy requirement. Oracle database is also a converged database. And by that, we mean that it can handle different types of workload, different types of application, and different types of data itself. Now, with Oracle database sharding, we can shard all these different types of workloads and data types and get the same numbers, same performance, which Matt just talked about, for any type of data. So those numbers which we looked at, you can get this for applications like online transaction processing, where we have customers like using in financial domain, like mobile to mobile payment, credit card processing, etc. Analytic applications like closing the books at the end of the quarter, or doing reports or billing or doing reporting around that. Or we can do things for applications around which are built using microservices, Internet of Things, where devices are streaming data from millions of devices worldwide are streaming data. Artificial intelligence, machine learning, all of that is available within Oracle database, and we can shard that, and we can do things like fraud detection by using anomaly detection, where we are scoring the model right where the data is inside the database. And as I said before, you can do this with structured data and unstructured data. So Oracle, of course, supports relational databases, rows, columns, tables. You also have first-class support for things like documents, where you're not talking about rows and columns, but you're accessing data as documents, collections, attributes, things like text data, like where you're doing a simple text search, sentiment analysis, clustering algorithms on top of text, graph, spatial. So we have a variety of data types, which is structured and unstructured data, which you can store in a single data platform, and we can shard it, and we can scale it to the same numbers as we saw what Luca has been able to achieve. And as I said before, we support up to 1,000 shards. That's also a logical limit, but you can actually spread this data across 1,000 machines if you want. and have scale out architecture for your different workload types, different application type, and different data types. So, Matt, if you could talk about some of the challenges and give us a peek into how BlueKai, what things BlueKai was facing before leveraging Oracle database sharding.
Sure. So, like most large-scale data platforms, the BlueKai platform has been developed and evolved over many years. And through that time, you're effectively going through the archaeological dig of big data evolution over time. And for the past 10 years or so, the approach has been to have a bespoke, targeted solution for the different types of use cases that we need to support within the platform. So you have a NoSQL database for the real-time, low latency type applications where the transaction is maybe less important than the latency. You have an OLTP database for your data that must be transactional and ensure that it is of the highest consistency. You have a Hadoop or Spark or other type of distributed data processing platform for your analytics use cases. You have a graph database and so on and so forth. Now you can imagine BlueKai, like other people with this type of architecture, things start to get complex. You have to make sure that the data is synchronized between these different data sets. You have applications that are pulling data from a data system A that maybe are different from a similar system pulling information from data system B. When you have an operational issue, you have to have really great understanding, transparency, metrics monitoring, alerting, and even then, you might not be able to pinpoint where the problem in your infrastructure is right away. So, if we take a step back and we think about how we got here because we didn't have solutions that could solve for all of those things in a single technology platform. But if we did have that, what would we build instead? And that's really what we tried to focus on here is if we did have a single data platform that could handle our low latency, NoSQL-like use cases, that could handle our analytics-like use cases, that could handle our financial applications where we need to have high confidence in the data set itself to handle the availability requirements that we need because we do have such a large data platform. We want something that's simple to operate, simple to understand, simple to execute on. And really, I think that's what the Sharded DB solution brought to us. Is it's going to be the beginning of an evolution towards going from multiple bespoke systems to a single system that can do all of those things well. Scalability is obviously very important to us. We have daily seasonality, meaning we have more traffic during the times of the day when people are waking up or having lunch or eating dinner than we do when people maybe are in meetings in different parts of the world. We have weekly seasonality. So on the weekends, our traffic profile looks very different than it does on a weekday. And then we have annual seasonality, things like Black Friday, the Super Bowl. These things impact traffic. And we need to be able to scale as our organic growth occurs, as the internet gets bigger, as the platform gets more popular. But we also need to be able to scale every day and every week and every year. And with moving to Sharded DB, one of the things that was important to me as a technical leader on this platform was that I wanted to have lights out operation where we could easily add a node or multiple nodes, and we can remove nodes to control cost when our traffic demands it. And Sharded DB does provide that. And really, this all leads into the costs. It's not just the cost of the servers and the data, which definitely add up when you're storing the same data in multiple places and you're having to transit it across the network to different platforms, but it's also the operational costs. How complex is it to manage these things? How much time is our team spending focusing on the operational platform when they could be focusing on developing new features for our customers, right? And so we look at all of that and say, we think that the Sharded DB is an opportunity to check all of these boxes. And I'm really happy to say that this was, a fantastic project with a fantastic result. And, the teams, my development team, the development team from Sharded DB, and the operational teams are all really delighted with the outcome. And we made this switch with zero downtime, zero customer impacting events. And now we're on our way to this simplified future.
Very cool. Yeah, that's really awesome. I think you touched upon some of the things around data consistency and lack of ACID property with sharding, sharded Oracle database. That is one thing we get, which is the scale of very much similar to many NoSQL products out there, scalability and the data volume. But we don't compromise on any of the aspects around data consistency, as well as transactions, joins, triggers, stored procedures, etc., which a lot of our customers are familiar with. So what are your thoughts around having those capabilities inside a data platform versus, applications will need them one way or the other. And what we see is that if you use some data platform where we are not, which don't support these capabilities inside the database, then applications end up building these capabilities within the application. So what are your thoughts on that and being able to leverage these and design new features as we go further?
Yeah, that's a great point. And it goes back to what I was saying before. If you go back into the sort of the history of time of NoSQL databases, they started out with no transactional support at all. Then many of the leading providers have started to add transactional support, but it's maybe not full transactional support, and it's certainly not ACID compliant transactions. And we in the tech industry have sort of gotten comfortable with that. Well, if you have a high volume, low latency use case, you just don't get transactions. And you need to have your application be aware of that. And you need to make sure that the data you're putting in there is something that is acceptable not to have transactions. And with ShardedDB, we're effectively able to take that cognitive load off of our team, because a transaction is a transaction is a transaction. If we get it right and the commit is there, we know that data is consistent, that it's stored, and that we don't have to add redundancy in our application to accept the fact that we may not have a consistent data set across the data store.
Yeah, makes sense. So let's take a look at the application architecture. So if you could walk us through how the application is deployed, what are the different components, and how the sharded database is fits into this mix here.
Yeah, so this is the architectural diagram for the BlueKai real-time application platform. And I think the beauty here is how simple it is. We have data coming in from the internet, just as HTTP here, but that really could be any protocol. Kafka is amongst them. When it comes into our platform, we process it on a microservice where our development teams can define business logic, customer features, subscribe to the right type of data. They all have access to our single data platform there, Oracle ShardedDB. We have the connection also to OCI's object storage. And this is powerful because we're able to have a single architecture that is storing data in Oracle ShardedDB as appropriate, but also in our object store. And that enables our offline processes to leverage data in both platforms. And it makes our workflows and application processes more simple. All of these things are then supported with delivery systems. If we're delivering data to our partners, we use Prometheus and Grafana for metrics monitoring and alerting. And we have Elasticsearch and Kibana for logging and analysis purposes of the platform. It's really not that complicated. And if you compare it to architectures that BlueKai has had in the past, or that other similar large data platforms have seen, this looks almost absurdly simple. But it creates a single API for development, a single platform to operate. It's got a shared nothing architecture so that we have extreme robustness. We'll talk more about how we configure ourselves across ADs and regions in the next slide. But when you have such a large footprint, when you have so many publishers and applications depending on you, downtime is not an option. And so we couldn't accept a solution that offered any of that. So we designed this in partnership with OCI and the Oracle ShardedDB team so that we have full confidence that our uptime will be on par with the best internet companies in the world. The thing that this also provides is end-to-end security. you have a surface area in any architecture when it comes to providing security for your customers, for your data, for your employees. And by having an architecture that's so easy to understand, we're able to control ingress and egress. We're able to control where data must be protected with encryption. We're able to understand who has access to that data inside of our platform. And if you can decrease the surface area of your architecture, your security profile is improved by default. And that's something that's very important to us here at Oracle.
Yeah, very good. And I could imagine that here where we are seeing a single database, probably at some point we had many different persistent store, different types of persistent store, storing different types of data. And as you touched upon, by converging into a single data store for a variety of data types, we not only get the high availability, scalability, reliability of that persistent store, but also security, where you only have one type of database to manage, patch, upgrade, secure, scale, etc.
That's right. And it's also important from an architectural perspective, it's just one database. But as you just talked about, and we talked about before, from an implementation standpoint, that's a whole fleet of servers that are providing service to the application. So for this deployment, what we focused on was we wanted to be robust against single server failure, but also single availability domain. And OCI and availability domain is a physical data center, because it's not impossible for a data center to go down, for a rack to go down with multiple servers on it. And when that happens, we needed to be sure that our application would be uninterrupted from the customer's perspective. So what we did was we created a footprint that was in multiple ADs, and eventually it will be in multiple regions. And the idea is that within a particular region, data is replicated across at least 2 availability domains. So if a single server goes down, that data is immediately available on another server in another availability domain. And because of Oracle ShardingDB's architecture, our application doesn't care. The query will be routed to the partition that, or the shard that has the data available. And we have worked to have automated scripts so that once a node is detected as failed, we can immediately use OCI to provision a new server and start hydrating that server with data so that we're very quickly back to our replication criteria. Now, once we split across multiple regions, now we can have multiple options. We can have all data available in all regions, or we can use filters to ensure that data that is most likely to be accessed in a certain geographical region from a latency standpoint is available in that region. So we get both redundancy across nodes, across data centers, across regions, but we also get geographic proximity, which is important for reducing latency from a speed of light perspective.
Yeah, that's very very interesting thing you brought up, where without sharded systems, if you want to do multi-region deployment, then potentially you would probably do some kind of bidirectional replication and have all traffic getting routed to either region. But with sharding, as you said, you could probably have a data being mastered in one of the regions, and that's where those set of requests for that data primarily go. And in case there is an outage in a region, then you could move that traffic to another region. So sharding, I think, brings another solution to an active architecture across multiple regions.
Yeah, and that's really important when you think about some of the numbers we talked about at the beginning, because if you're having ingress and egress across regions in the types of bandwidth that we're relying on here, it gets both really expensive, and in some cases you run out of bandwidth, right? There's just, the pipes are only so big and the speed of light is only so fast. So if you can be intelligent about what you replicate and when across regions, you can get the redundancy that you're looking for without extraordinary cost. And
what are the business impacts? I think we talked about technology, we talked about architecture, we talked about how it is getting deployed in Oracle Cloud and sharding, but how is this architecture using sharded database in Oracle Cloud helping us serve our customers better and have a better impact on the application itself?
So the first is that we have full confidence that as the platform grows, as our customers grow, which obviously we hope for, the ShardingDB infrastructure is there to scale with us. We have full confidence that we can grow far beyond what we're doing now, because even though the numbers are quite significant, the scaling has proven to be truly linear. If we add another machine, we can continue to scale out the same number of transactions on that machine with very little impact on the overall performance of the system, and most importantly, latency. So, when we talk about latency from a scalability perspective, from a performance perspective, for the DMP, speed is life. Because if we're slow, we don't get the data. If we're slow, we don't respond quickly enough to take action when someone might be visiting a website right at that moment. And if you don't respond in time, you've missed the opportunity. And in previous implementations of our architecture, we did find that what we thought was acceptable at the time, maybe 2 or 3% of the transactions just didn't finish fast enough from our own SLA perspectives. But that was effectively the cost of doing business. With ShardingDB, we've seen that error rate go down to 0. And with the deployment, as I mentioned before, we've been live now for, I think, maybe 4 or 5 months with this platform, and we've had 0 customer impacting events. We have had servers go down. If you run a large fleet, and anyone who runs a large fleet of servers knows that servers go down, whether it's because of a software issue or a hardware issue. That's the expectation. The modern cloud native application development practices are such that you shouldn't care if a server goes down, and that's true for our applications, and now it's true for our database as well. Seamless failover, and the stability of the system has really been the thing that I've been most happy about, pleasantly surprised, because anytime you roll out a new system, I don't care what kind of system you're talking about, but anytime you roll out a new system in an existing architecture that has the type of traffic we're talking about, you expect hiccups, you expect problems out of the gate, because the problem domain is so large. And credit to the team, credit to the architects of ShardingDB, but we've rolled this out without a single incident, and that's something that we're very proud of.
Very cool. And I think in terms of performance, I believe we had a performance improvement over some of the key value pair stores we were using in the past, and that is something may sound a little counterintuitive. So could you talk a little bit about that?
Yeah, sure. So, typically we choose NoSQL data stores because they're fast, because we care about latency. And when we moved to ShardingDB, our expectation was that, hey, if we can go as fast as we were with our key value implementation, our NoSQL implication, that would be good. But to our surprise, when we rolled out this system, we were seeing latencies that were 20, 30, sometimes 50% faster than in our NoSQL implementation. So, again, to have that kind of latency in a ASTIC compliant, full scale, full function database is something that I think is a game changer, not just for DMP, but for any customer out there that has this type of use case.
Yeah, very good. So what are the benefits to the end customers of moving to this architecture, using a cloud native sharded architecture?
The ultimate goal of the DMP is to provide actionable intelligence effectively, so that marketers, publishers, advertisers, data providers can effectively create campaigns, create audiences, and ultimately grow their businesses. And by having Oracle ShardingDB in the BlueKai architecture, we see a future where we'll be able to provide richer analytics, richer machine learning, better understanding of relationships between content on page, people's behavior on those pages. And we think that we can drive a better outcome for our customers as a result. So, when we sort of bring this home, today, when we run our analytics processes and we do them offline hours later, it's good and it's providing value. But there's a future where we'll potentially be able to offer those types of analytic queries and audiences and modeling in near real time, just the same way we're serving our events today. And that's something that's going to be pretty special.
Great. So we have many customers who are looking at similar architectures. We have customers who have experienced data growth over the years, 50, 60, 70, 80% year-over-year growth. What would be your advice to such customers who are looking to scale like we are able to scale here at BlueKai?
Yeah, from my perspective, I think the most important thing we can do as architects, as executives, is to occasionally take a step back and ask ourselves, are we on the right path? Is the current course and speed the correct course and speed? And something I've been talking about lately is that for roughly the past decade and a half or so, there's been a right way to develop these types of systems, and they typically look like some sort of API gateway with a low latency, NoSQL type database, with a transactional database for your financial information, and OLTP with a offline data processing like Spark or similar distributed data processing system, multiple workflow engines. And you keep adding one of these things on at a time, and it doesn't seem like a big deal. But before you know it, you've got an architecture slide that you need a microscope to see the different elements because there's so much to pack into those pages. So my advice to everyone on this webinar is to take a step back and ask yourself, do you need every single platform you have in your architecture today? Where are you making decisions because it was the obvious right thing to do maybe 5 years ago, where today there are better technology solutions that might allow you to consolidate and collapse your architecture, because that simplicity will give you better operational uptime. It'll give you a smaller footprint to manage. It will let you develop your features and functions faster. And you get a better overall outcome from a performance and a data perspective. So, number one is simplify. And then my second piece of advice is, the future is here. And this is not something I think is new to people on this webinar, but I think it's important to call out. But if you're building a system that has a scalability red line, where if you go above a certain amount of traffic, you fail, that may not seem like a big deal now, but you may hit that point where that's the difference between your business growing and hitting an operational bump that causes significant disruption. So if you build that elasticity in every aspect of your architecture from day one, you'll never have to worry about that.
Great. Thank you very much for explaining the architecture and the lessons we learned by going through this journey. And if you want to learn more about Oracle Sharding, here are some of the links. We also have a live lab on Sharding, which will be available shortly. And in this lab, we will talk about how you can design your schema, how you can code your application to scale just like BlueKai, and go to a planet scale without having to come up with the complicated data architectures and complicated application designs.